1 on x is less than or equal to 2. Okay? Now, I don't have to do any algebra to this if I think about this as my approach. Okay? Which is kind of cool. I like that. Right? Think about it this way. 1 on x. What is this shape? It has a name. It's a hyperbola. If you want the technical fancy name, it's a rectangular hyperbola, but we'll get to that later, maybe. Alright, now I'm looking at less than or equal to 2. I should probably mark in some asymptotes. There you go. Again, I'm not being all that fussy because this is just a mechanism for me. Okay. Where's 2? 2 is going to be, well, that's that point there where these distances are equal is going to be, does anyone know the coordinates at that point? It'll be 1, 1. Right? So if that's 1, I'm looking like twice that high. So something like this. Okay. Now I'm looking at when it's less than or equal to that value. Okay. So again, let's take Nikita's approach. Okay, which parts are okay? This part's okay. It's below my 2 line. And this whole branch over here is also completely fine. Okay, so without appealing to any algebra, just off the basis of this diagram, I can say, right, from the diagram, in fact. Again, just like here, I've got 2 different parts that I'm looking at. How would you describe this part? What bounds it? Its x is it greater or lesser? It's less, because I'm starting from here and going that way. Okay, so x is going to be less than 0, and even though I have a boundary included here, I don't have a boundary here. Why not?
Because it never touches.
Right, I never actually get there. So I can't say, oh, it could include 0 too, because I can never actually get a sensible value out of that, right? There's one part, and then I have another part, right? And this time it's from here going to the right. Now think, it's a very simple graph. What's the x value that's going to correspond to that? You can almost see it because I've drawn it accurately enough. It's a half, isn't it? Because I plotted that as kind of 1, right? And it's just the reciprocal function. 1 on x is the reciprocal function. So the reciprocal of a half, sure enough, is 2. Okay? So I've got x is greater than or equal to a half. That's great, right? Minsu.
It's better to state x cannot be 0.
Okay, very good. I could have, now I will actually go ahead and do this. If I didn't want to go and do this graphically, right, because sometimes it's not so nice and neat, and 1 on x, you know, we've seen 1 on x 100 times, right? It's not always so neat, okay? It might be shifted this way, that way, all that kind of thing. So you may have to appeal to the algebra to solve that. So let's see what we would do if that was the case. Right away, I should note the restriction that x can't equal 0, okay? But then what I'm running up against is the problem I had before. In order to do any work on this, right, I've got a couple of choices. I can try and take some reciprocals, right? Because you can do reciprocals in equations. If I said 1 on x is equal to 5, right? All I need to do on this side here is to flip both sides. I can do that. This is x on 1, and this will be 1 on 5. So x is a fifth, because 1 on a fifth, sure enough, it equals 5. Okay. But, what happens when you do this for an inequality?
So
Is it times e by minus 1 plus the sine?
Okay, right. So if I were to write this, let's flip that, okay? And then I've got less than there, and then I'll flip this. You can already see, because we worked out the solution, you can see this is wrong, okay? So if I'm going to take reciprocals, think with me for a second, and you already know what the answer is. If I take reciprocals, what should I do to the inequality? Yeah, Aaron.
Multiplied by e squared.
Okay, I'm going to take that as my second approach. I'm going to do that in about 30 seconds, right? But if I would just take this line of argument, what should I do to this side? Yeah.
You make 2 regions, like x is bigger than 0 and x is less than 0.
Okay, so you can take cases. You can take cases. But just looking at this line of argument and knowing what my answer is, surely I should just flip this inequality. Okay. Now, am I allowed to? Well, let's think about this for a second. It's a bit tricky because there's algebra. We've looked at problem-solving techniques before, right? And one of the ways that you can tell whether algebra is right or wrong is to think about whether you can do the same things with concrete numbers, like actual numbers that you know what they are, and see if that works, okay? So let me give you an example of an inequality that I know is true, okay? We'll come back over here. This is stuff that I know is true. A half. A third. These are not equal. But I can write an inequality between these that would make a true statement. What kind of inequality should I write?
Half is greater than.
Half is greater than a third. At least last I checked. Okay.
Oh, but the
Now,
thing is-
if I were to take the reciprocals of both sides, the reciprocal of this side is 2, and the reciprocal of this side is 3. So what's happened to my statement?
It's switched.
Well, in order to make it true, I'm going to have to switch the direction of the inequalities. And that's fine. Okay? So can I do this? Yes, I can, because that's how inequalities work with reciprocals. Just like if I were to multiply by negative numbers, right? Let's go again. Let's just take this line. 2 less than 3. If I were to multiply both sides by -1, I would write -2 over here. And then I would write -3 over here. What's happened to my inequality sign? It's flipped again. In fact, it's kind of flipped back. Okay? Why is that true? Because that's the way inequalities work, right? You can think about it in terms of absolute values, right? If you slap a negative sign on it, I'm going further away, but in the opposite direction. So that's why it's greater than or less than, depending on which values you're comparing. Okay? So, this is fine. This is a true statement. But it's not all, is it? Right? And it's not all.
Lost this.
We've lost a solution, haven't we? Okay? So here's the way you get it back. This is a simplistic way to think about it. Okay? I'm going to go to Aaron's suggestion now. The reason why I'm sort of having these problems is because I'm trying to work with x, but x is a variable, right? I can't just multiply by x, right? Unless I want to do 2 cases. Avoid cases wherever you can. Sometimes you can't, but where you can, avoid them. To avoid cases here, I'm going to multiply by something I know is positive, namely x squared. Okay? So if I multiply this by x squared, and I multiply this by x squared, do you see what we've done? Okay? We've created now a quadratic problem. And a quadratic problem is going to have 2 solutions. Watch what kind of solutions we're going to get. What's my left-hand side? X. It's just got 2x squared there. What should I do to this thing? Put it all on one side. Okay, so at least on this configuration, I have this. I don't like negatives. Okay, so I'm going to multiply by -1 and switch the direction of my inequality, which gives me this. Happy so far? Okay, now what? Factorize. Take the x out, right, which gives me 2x minus 1. Aha, okay. So now you can see this is a parabola, and as with all other parabolas, it's got 2 solutions, namely 0 and a half. Aha, but pay attention, okay? Here's a half, here's 0. So what does this parabola look like? It's the right way up, so it looks like this. It is pretty narrow. Okay. All right, now look carefully at this with me. Okay, this is why I'm glad Minsu mentioned this thing first off. Okay, I have this. I want to know where it's above. Okay, so look, here's one part. Okay, which is here. Yep, inclusive of boundary to the left. Okay, yep. And then I've got the left-hand side, as I did before. Right, no big deal. Aha, except. My very, very first line of working, which is exactly right, is I noted there was a restriction. Before I did any of this business, I said there's a restriction, x can't be 0. Because I multiplied through by x squared, which would be 0, which would be a problem. So being that x equals 0 lies within the domain of my solution, I have to take it out. So that's why it becomes that, which is exactly what I thought it was in the first place. Okay? Does that make sense? Question.
It doesn't make a difference whether you make it upside down or not, because
Because this thing would look like this, and I'm looking for the parts beneath the axis because I haven't switched the direction of the equality. It's all fine. So it's the same question. Yeah, Docs.
In this test, if you just drew the graph and got a solution from that, would that be fine?
You mean if I'd done this way?
Yeah.
Yes.
Yes?
Yes, it would be fine. In fact, well, depending on the question, the exact question that I get, it would be harder or easier. But this is actually a superior way to do it. Can you see here? Just compare the amount of work. Admittedly, it's because it's 1 on x, so I don't need to do any work. I know exactly what it looks like. Okay, but here you've got to fuss around with the algebra. There's lots of places for it to go wrong, and then you have to note the restriction. Whereas here, I have no problems like that. because I knew what it looked like. I knew what the actual question was. I didn't convert it into another question. Do you notice this question is not this question? Right? This is a hyperbola and this is a parabola. These are different. To make them equivalent, I note the restriction, and that's what takes out the boundary there. Okay? So this is actually a superior way to do it. But if it's harder, if it's messier, like if I don't know, like if it's something like this, 3.5, something like that. Like just the numbers make it a bit messy. Just messier enough that it's like to be sure I'm getting my right values, because I don't know what 1 on 2x minus 1 looks like, like that. It takes me like maybe 30 seconds to make sure I get the asymptote right and the shift and whatever. For that case, I'd probably go to the algebra just to be sure. Okay, but if you get a question like this, and it happens all the time, okay, there's nothing wrong with appealing to a graphical solution so long as your graph is good enough to make the solution.